So this was like built on Linux kernel. So that's the reason this mobile operating system even helps you to work on like forking the program, so that you can work on multiple things. See, let's say when you are working on some application, so something is downloading in the background. So it helps you to provide like multitasking with the Linux kernel. So that's the reason mobile operating system, this Android is based on the Linux kernel. And basically, how the user interface or interacts with this system is only through the touch screens. Okay. So the Android system was introduced later after the smartphone. So during the smartphone era, it was only like a few BlackBerry or Symbian OS. So some specific OS were there which are proprietary. So after that, this touch screen has got the interface. And if you see world over, it's like overall 80% of the users are using this Android. So that's the reason there is a lot of need for Android developers to work on different applications that need for the Android. Okay, so uh, it powers devices like watches, TVs, and cars. So the Android even supports you to write programs into wearables as well. So that's the reason the Android operating system even works for these wearables as well. Okay, so and it's like millions of Android apps are released on Google Play Store. So if you see in 2019 itself, it was 3 million. So probably now it has gone to 5 million Android apps in Google Play Store. And one advantage is that highly customizable for devices. And I mean, even by the vendors also, it's more useful. See, as the Android is open source, the advantage is that you can program that, and whatever you program, you can release it or add on to the developers. So androiddevelopers.com is one website where you can release or deploy your thing, so that which will be open for everybody and the others can even reuse it. So it is like highly customizable for devices. So for each and every device, the user can use his or her own design perspective. Okay, so that is one advantage. Okay. If you see how the user interacts with the Android or the mobile phone or in which you have the Android, so we have like touch gestures. So we have like swiping, tapping, and pinching. Can anyone tell me what is the difference between swiping, tapping, and pinching? What is the difference between swiping, tapping, and pinching? Anyone?
Uh, Swiping means
Swiping means
Yeah, usually when you scroll up and down or when you want to close your applications, you will be using swiping. Yes. And then tapping.
If we want to
to
open
open
any
the
webcam.
application.
Yeah. So basically tapping is like selection. So whenever you want to open an application or whenever you want to select a particular thing, you will be using tapping. Then pinching.
Zoom in remote.
Yeah. So in order to increase your size of a particular item or like zooming in and zooming out, you will be using two fingers to do that. So that is why it is called pitching. And you also interact with the applications or the Android by using your virtual screen. I mean, virtual keyboard. So you'll be entering the characters, numbers, emojis. So all these things, right? So in that way, you will be interacting with your Android system. And also like you also have connections to Bluetooth, USB controllers, peripherals. So all these things are also like supported. So with all these three varieties, usually the user will interact with the Android Studio. I mean Android system. Sorry, it's like the operating system or with the mobile which contains the Android as a operating system. Okay. Okay. So and then you have like sensors as well. Okay, so when you come to sensors, why do you need them? See, usually whenever your mobile is moved or like turned or changes its position, so the user needs to take appropriate action based on the movement, and based on that it should respond to that action, right? So let's say, for example, if you have rotated your device, so when the rotation is happening, whatever was visible in a portrait mode, it should now start visible in a landscape mode, right? So the device content rotates as needed. So how does it recognize the mobile is turned left or right? So whether it is straight or towards left, so it has some inbuilt sensors which will be detecting the motion of the device, and based on that, it will be rendering the content. Okay. And then walking adjust positions on map. So whenever you're moving, or like you have some apps which counts the steps, or let's say you are using a GPRS for moving from one place to another place. So how is it identifying the total distance from your location to that place? So based on the acceleration that you are moving, it is identifying, and then by what time you are reaching there. So a sensor accelerometer will be there in your mobile, which will detect that, and based on that, it will be responding to the user, whatever the things are happening. Okay. And then tilting steers a virtual car or controls a physical toy. So sometimes, like whenever you're playing with a virtual car or some physical toys, you'll be rotating the screen left and right, or you can use some buttons to navigate. So in order to do that, you have to communicate with the sensors, right? So that is how you need see, in your engineering clinics, probably you have used driverless cars, right? So during that time, you will be building up some app which controls that driverless car. And so left, it has to move left. When you click on right button, it has to move to right. So it is even providing an environment where you can interface with the IoT based services as well. Okay. And sometimes when you are playing some games, or which are like more interactions are involved. So when you move too fast, sometimes the game interactions will be disabled. So that's how, like, in order to sync with the graphics card and all these things, even these sensors will be like reporting that information. So this entire sensors are like useful for updating the content based on the user's performance or the action. Okay, so this also places one important feature. Okay, so till now we have seen like the user interaction, so the gestures, the keyboard interaction, and this plays one of the important role. And we have the sensors, so sensors plays a vital role in identifying the displacements that are happening on the Android system. Okay, so next is like the home screen. So whenever you are looking at the Android device or Android system, so you have like mostly on the screen, what are you see? What will you see on the home screen? So you will see different launch icons. So individual icons that you can see, and self-updating widgets for live content. So sometimes you'll be registering for weather forecast, like rain will come or not, what is the temperature. So so different live content updates also you can have it on the home screen, right? And some sometimes you can have multiple pages, two or three open pages also you can put it on your screen. And you have folders, right, on the home screen as well. So in the folders, again, you will have multiple applications installed, so that will be there. And also you have a OK Google to do the operations. Okay, so this Android home screen contains all this stuff. So this is also one important aspect for Android system. So if you see different applications, so application is nothing but a small program that is used to provide some activity to the user. So Here different applications are given, so which will be running to meet the specific needs of the user, right? So these are some examples of the Android apps. And the next, so we have seen like the interaction, user interaction is one ecosystem of Android. Sensors is another ecosystem of Android. We have seen the design like home screen. All these things comes as one requirement. And another one is like Android software development kit. So this is the one actually the core of the Android application development. So when you are working with development tools, like you have the debugger, you have the monitor, you have the editor. So here, editors are the place where you will be writing the code. So you will be writing Java codes, you will be writing XML codes, and monitors are the place where you can preview your application. Okay, so where you can preview it and you can work on it. And debugger is where you will be working on the project, whether it is executing smoothly or not. So these are the things that with which we will be working on. And then we have libraries. So libraries are the add-on facility. So what you will do is like, let's say you in your application, you want to add some app or map. Okay, so you need to figure out where you are located. So in that case, the maps related libraries are available. So what you'll do is you will include those libraries into your program or the project, and then you will be working with them. Okay, so you'll be working on the classes related to the maps. So similarly, if you want to put your program into a wearable like a smart wristband or something like that, or even I mean, few new latest wearables are also into picture. So what you do is like you just need to incorporate the libraries associated with that, and then you need to work with that program. Okay, so this is one important aspect where you can add more features into your SDK, and then you can work on different programs. Okay. And the next one is virtual devices. So when we talk about virtual devices, whenever you are installing this Android software development kit, so which is nothing but your Android Studio. So when you are putting it, so it also gives you an emulator which replicates the exact appearance of the mobile phone. So whichever mobile you choose, so there will be a number of application models or the Android models that will be available. So you'll be selecting one. So once you select, let's say, Nexa some 1000 by 1200 size, screen size, so it will emulate the exact version onto the Android Studio. So whatever the program that you execute, it gets emulated onto the emulator. So basically here you have two things. One is emulator and another is simulator. So basically emulator will be creating its own memory, and then to execute it, it needs separate resources and do the program. There is another simulator which is used by an iOS. So there it is like a shareable one. So that's why as it shares the memory space and everything, it becomes a lightweight and executes faster. But whereas Android Studio has an emulator which will take like around 4 GB of RAM to just execute. So that's why your RAM size should be minimum 8 GB to execute your Android Studio. Okay. And then documentation. So in order to do the documentation, you have this developers.android.com where you can get resources which are already available, and you can even like add on to the documentation by providing some information. Okay. And this SDK will also provide you with sample codes, so which you can use it and work on. So these are the this is one of the important ecosystem of the Android. So Android software development kit, which is actually used for programming the apps. Okay. So if you see one of the Android Studio development kit is this Android Studio itself. So here if you see, the window looks like this. So probably tomorrow I'll be taking you through that. So it looks exactly similar to like an Eclipse or a NetBeans that you have used earlier for Java program. Okay. So if you see the Eclipse or like NetBeans, so here also in Android Studio, the left side, this one is called the project area. Okay. So if you see the project area, you have two things. One is app and the other is Gradle script. Okay. So app is the one which contains all the information related to your application. Okay. And Gradle script is the one which is responsible for loading your application and then adding the dependencies. Like I told, maps or something variables related things if you want to include in your app. So you will be copying that dependencies in the Gradle script and you will be executing them. Okay. So you will be finding two things. One is like Gradle script, which will add or works like a linker. It will load the dependencies and then attach with this application and then it will try to execute. Okay. And if you see in app contains like three important things. One is like manifest, Java, and resources. So application contains three things: manifest, Java, and resource. So what is manifest file? Manifestation is like bringing it to the life. All right. So when you launch your application or when you load your application, what do you need to do is like that application needs to be launched or activated whenever you click the icon, right? And the internal Java sources that were saved that needs to be activated and it should show that application. So in order to launch that application, you will be needing this manifest files. Okay. So this manifest file is one which is responsible for loading the information. Okay. And next comes the Java files. So if you see the Java files, these are where actually you'll be using the code for programming the logic part. Okay, so you will try to access what are the elements that are present on the app. Let's say button, input box, text box, like that, different things will be there. So you'll be actually accessing them and you'll be writing logics for them. Let's say username, whether it is appropriate or not. Like password, it should have a special character at the rate. Some logic you'll be working on. So that logic part we will be doing with the Java codes. Okay, so that is one thing. So manifest file for launching the application on the screen, and Java is for writing your program logic. And the next one is resources. So resource here is something like we say the entire components or things that are needed for your application. So let's say here what you see is like under resources, you have drawables. Drawables in the sense if you were, I mean, if your app has some images, so you need to include all those images in the drawable folder. So images or clip arts or GIFs, whatever you want to add, you will be adding them onto the drawable folder. Okay. And the second one is layout. So how to organize your items. So let's say you want a table representation, or let's say you want to align them in one after the other, like a linear layout, or if you want to align them in a frame layout or grid layout. So how do you want to align them? So that layout is present in this layout folder. So basically, these layout folders are programmed with XML programming. So in the first day, I was talking like rather than HTML, here we will be mostly using this XML as a resource programming. So how to include button, how to include like different images. So all these things we will be doing it in a programming representation. Okay, so which is done in XML. Or else what we can do is like through design also you can do it. So you have a palette here. So palette of all the items. Okay, besides this project. So the
Ma'am,
layouts are there. Yes, ma'am.
We will learn these things in theory class or only in lab, ma'am.
This one, see, from next on, you will learn practically only, very less of theory. I'll be telling you theoretically, and at the same time, I'll show you the side by execution.
So the CAT exams will be practical, ma'am, mostly.
Mostly will be practical.
Okay, ma'am. Then the theory which you taught us last class wouldn't be so much of in the questions, ma'am.
It can be there. See, probably we'll give it in a different perspective. So, as this is like, let's say if it is CAT 1, only module 1 and 2, I have to give the questions. So, in that case, I can ask some questions from the ecosystems or all these things.
Okay, okay.
Yeah. So, not greater, but then there will be some extent of questions coming. Let's say if it is 50, so then, well, like 20 questions can come from, 20 marks can come from module 1, and the rest 30 will be from module 2, like that.
Okay.
And here, when we are working with this palette, so you can drag, drop, and put it at the positions wherever you need. So automatically this XML code gets generated. So that way you can do, or you can directly edit it in the XML itself. Okay. So in these two ways, you can design or create your appearance on the on the application. Okay. And then you have min maps and values. So min maps is something like, see, you're designing your app, let's say 400 by 500 size. Okay. And you want to now, let's say somebody else is loading for a size of 1200 by 100 megapixel size. So if it is that case, so your application should be feasible for displaying in all kinds of versions. So here in MinMap, you have like different resolution criteria. So you have minimum dots per inch, high dot per inch. So I'll be telling you about them in detail when I show the actual process. Okay. So I'll be talking these things once more when I show visually the application, so that it will stick to your mind. Okay. So all these things you'll be doing. And on the right hand side, or sometimes this component tree can appear here itself. Okay, so this will be a component tree structure. The tree structure will be giving you the hierarchy in which the elements are organized. Okay, so actually this is the device screen. In the device screen, this is the linear layout they have added. In the linear layout, one is like the text view, we call it, or a label or a paragraph. Okay, and then you have a edit text. Edit text is something where you can enter. So in web technologies, the text field, we call it as edit text in Android. Okay, and the buttons are same. Buttons will be there. Okay, so this is how we do it. I'm in class, Bindu. Okay, so this is how we be doing it. So the tree structure will be showing you what are the elements that are present here. So if you click each and every element, you will get the properties. So if you want to change the properties, the color, the appearance or alignment to the center, left, the background colors. So everything you can change by using the properties, or directly you can code it in the XML itself. So these are the different ways in which you can load it. So if you click this link, you will go to the official Android IDE site, so where you can download the Android IDE. Okay, so you can install them. Once you install, how to write the program and all, I'll be explaining you. Okay. So monitoring and performance tool. So you can verify here itself the preview of your application, and you can monitor what is happening. Okay. And virtual devices, as I told, an emulator, the same phone, it will be emulated outside when you run the program. Okay, so the emulator will be displaying all the content. And project views. So you can view the project, and visual layout editor. So here you can drag, drop, and add the layouts visually. Okay, so which makes little easier for you to work on. Okay. Okay, so you can publish the apps in Google Play Store. So I'll be talking about this in detail later once you are going to deploy your, apps. Okay. So next is, see, so all these things make an Android ecosystem. So the operating system itself is an ecosystem, and the sensors, the user interaction, right? And the Android software development kit, right? So that is also playing an important role, and the IDE, so to execute and run the programs. Okay, so these are all the things that make up the Android ecosystem. Okay, so now let us look into like the Android platform architecture. Okay, so how the architecture of this Android is built upon. Okay, so if you see the Android architecture, so the first things you will be looking in is system apps and user apps. The next one is Java API framework, native libraries, and Android runtime environment. And then the hardware abstraction layer is present and the Linux kernel. So these are the layers that are present. So basically, when you are working with any of the application in your mobile phone, you see two kinds of apps. One is system application, another one is users applications. So what are system applications? So system applications are the applications that are provided to you during the time of purchasing your mobile. So inbuilt you will have the calling, you inbuilt you have the SMS service, inbuilt you have the Wi-Fi connection modules, inbuilt you have the Bluetooth services. All these things are like inbuilt available with the system, right? So that's why we call them as system applications. And they don't have any specific status, or like you won't see any status bars on the system application. So later when we work in detail, you will understand that. And user application is the one where the users will be creating or using the applications by downloading from the Play stores. So for example, let's say you have installed a Truecaller, okay, and you have enabled the Truecaller as a messaging service. So when you use this Truecaller, what happens is like when you are sending a message, okay, so it actually use the system's default messaging service. So that's why even if you use Truecaller or the other messaging service which is built on top of your system's message service, then all the charging and all the SMS charging, everything will happen based on your default system application only. But then the appearance is now being changed. Okay, so you can access the system applications by using some inbuilt libraries and you can program them. Okay, so the best example is user application is a Truecaller, whereas a system application is a default SMS service that is present within the mobile system. Okay, so that is the main difference between system application and the user application. And the next one is Java API framework. So basically, we have the applications. So how are these applications built? So to build this application, you will be needing a Java API framework where you'll be programming what the application should do, or what actions it has to perform. So, okay, so the logical part on the design part, you will be working on this framework. Okay. And the next level is the native C or C++ libraries, and you also have this Android runtime environment. Okay. So what is the need for this native C or C++ libraries? So these libraries are basically used to build the platforms for Java API framework. So you have to work on them. So whatever the modules that were inbuilt, like the emulator to be launched, or the project should be arranged, or let's say the debugger needs to be worked in this way. So all these things, let's say you have to start a Wi-Fi connection, or let's say you want to access a camera or a mobile phone. So how to add the interfacing, or like how to add the libraries related to the Android Studio. So the entire Android Studio is built upon these native libraries. On top of that, by using our Java API framework, we will be programming our applications. Okay. So that is a basic idea. And then you need this Android runtime environment. See, once you prepare your application, so the end product will be coming as .apk file. Okay. So this APK file, what you will do is it is installed into your devices. So once it is installed, you will not be installing entire Java code or all these things. So the entire executable APK file will be loaded onto your mobile phone. So once you click on it, it just executes. So this Android runtime environment should provide the environment where it can execute that. Okay. So which is similar to your JVM. Let's say you were working with Java, right? So you have a JDK and you have a JVM. So what does a JDK do? It just compiles and give you a bytecode, right? So if this bytecode not just in the same machine where it executed, so if you copy that into some other machine where the JRE is present, Java runtime environment is present, that bytecode will execute automatically. So it's not necessary that the JRE should be present on the same system. So that's why Java has a platform independence. Okay. So similarly, your app, if it is loaded in any of the mobile apps which has this environment, then it automatically executes efficiently. So by default, every Android system comes with an Android runtime. Okay. So here this runtime is known as Dalvik runtime environment. Okay. So this helps the apps to execute on your Android systems without using any like loading the Java code or all these things. It just bundles up or what to say, it just makes it as a packet and then sends it. Okay. And we have like another thing is like hardware abstraction layer and a Linux kernel. So what is this hardware abstraction layer doing is that, see, let's say you want to take a camera, right? I mean, take a picture. So you need a camera to work on it. So if you want to work on the camera, what you need to do is you need to talk to the operating system because it is a device, right? Kernel is a Linux kernel is a device. I mean, it's directly related to the devices that are connected to it. So it's like an operating system only, Linux. It does all the device management, memory management, power management, the scheduling of the action. So all these things are taken care by that. So if any device is needed or if the camera needs to be accessed, so this hardware abstraction layer provides as an interface with the OS to make the system call to activate that camera. Or let's say you want to listen to music. Now the speaker needs to be on. So this hardware abstraction layer will make a system kernel call to the Linux, which in turn will activate that particular device. Okay. So this is how the entire architecture looks like related to the Android. Okay. If you go a little deeper, so here the system applications are like, let's say home, for example, and the user, I mean, the default applications can be contact, and on top of it, you can write your own applications. Okay. And when I was talking about the Java application framework, so this will be taking care of activity manager, which is like nothing but designing the application. So designing the activity and designing the whole window, how to represent your application, or if your application needs some third party transfers, how to send the content or content providers within them, and how to see them, like what are the resources needed. So to program the entire Java thing, we have this application framework. Okay. And I was talking about the native libraries, right? So let's say if you want to get in touch with the media, so there are some inbuilt libraries available with which you can connect. let's say you want to load into SQL. So the SQL connections are built with this native libraries. Let's say you want to work on graphics, let's say OpenGL and graphics you can use and you can program them. Similarly, free type is for fonts, different fonts if you want to try it out. So you'll be using this free type, and SSL is like for providing a secured network protocoling, so which will help in communication. So wherever the application needs some other interactions or like things, so in that case it has a specific inbuilt libraries with which it is developed. Okay. And as I told, for the Android runtime environment, you have this Dalvik virtual machine, which will be working on. Okay, so and then the abstraction layer, actually, if you want to access the device managers, device drivers, you have the Linux kernel. Okay. As I told, system apps have no specific status. So system apps provides key capability to the app developers. Let's say your app can use a system app to deliver a SMS message. So I told you an example of Truecaller and a inbuilt system app. Okay, so a system messaging service. And as I told, the entire application, how it should be working, or how the screen should look, how the notifications should be scheduled, or how the interaction should happen from one page to another page. So which we call it as Activity Manager for life cycles or navigations. Okay. And then how to provide information to other apps. So all these logical concepts that are related to your app will be working with the Java. Okay. Java API framework. And then we have the Android runtime. As I told, each app runs on its own process, which is, let's say, which is called as its own instance of runtime. So because if your app needs to be run, there should be a virtual runtime environment to be on which it can execute. Okay. So there are 4 libraries and Dalvik virtual machine which will help your application to do that. Okay. And when you compare to this DVM and JVM, so Dalvik virtual machine and a Java virtual machine, so Dalvik virtual machine actually is lesser weight when compared to Java virtual machine, because Java virtual machine, they have made it as a compact and it needs to be executed with lesser memory and and it should execute very faster. So that's the reason whatever the contents that are needed for your mobile application to be executed, only that core libraries will be available with DVM. So the programming aspects like JVM and all will be looking like creating the environment. So here DVM is much lesser in storage and it takes very lesser when compared to the Java virtual machine. Okay. As I told, native libraries. So to access core native Android system components and services, you need this core C or C++ libraries. Okay, so for accessing the SQLite, let's say free type, or free type is for fonts and WebKit is for connecting to the web pages, and then media, and then other runtime libraries. So anything is like if it is the core native Android system components, so those are built on with this C or C++. Okay. And HCL is like standard interface that expose device hardware capabilities as libraries instead of directly showing them as a camera access. So there will be a camera interface which will be like providing the camera facility. Okay, so camera, Bluetooth module, so speakers. So all these things are like the hardwares that you are adding in. To that, it provides a seamless interfacing between the device and the kernel. So as I told, kernel would be the, root of the entire architecture. So the kernel will be taking care of all the aspects related to your application or the Android. Okay. So it is responsible for like device drivers, so to activate a particular device, and power management, so the battery management of your Android, memory management. So your let's say your space is got like, let's say, only 64 GB space in your mobile. So how to manage that, right? And then device management, resources, how to access the resource. So all these things are like taken care by the Linux kernel, which is something like an operating system that we look in for our if you look in as aspect of a laptop or a desktop, something like that. There also it is doing the similar kind. And this also provides you with a threading and low-level memory management. So that's what, whenever you are executing something, something will be happening in the background, or something will be downloading, or somewhere the weather app is getting updated with the weather things. So you will be receiving the notifications. So all these things are like, uh, I mean, taken care by this Linux kernel. Okay. So now, if you see the versions of Android Studio, so the earlier versions are like A and B, which are like not released versions. They are like a beta tested versions. So that's the reason usually we will not talk about them. And we also have these other things like, it started with a cupcake, then donut, and then eclairs, and then Freo, gingerbread. So like that, we have different things. So earlier, in the last versions, we have like Pi, and before that it was Q. In between, we got this Oreo as well, right? And now, what is the latest version that is available for the Android operating system version? Anyone? What is the latest Android version?
11.
Yeah, it's
11.
11. It's not that given the name, right? So, and then what is the reason for giving the food names as the versions for this OS? So I just want you to Google it and explore for yourself. Okay. So, and then if you come and look into the versions, like for each and every release, there will be like different versions. So 3.0, after 3.0, if 2 is there, it's a major revision. Dot something is there, it's a very lesser version. Okay. So like this, for each and everything, there will be a version level, and then the API levels are also given. So what does this API level do is, let's say you are working with an Android, I mean SDK, right? Android Studio, you will be working for programming. So the Android version levels are indicated here. So the APK levels will be specifying with the Android Studio. So if you want to work with, let's say, an API level 21 to 22, your Android Studio should support that API level. So you need to make sure the platform where you are executing should able to load this Android operating system. So that is how we need to map them. So if this is working at this level, so your Android Studio should be having this API level support. If it is not there, so it won't be supporting the other, I mean, they're supporting this lollipop. Okay. So like this, we have a deep level of versions. So I want you to explore like um, uh, why the food names given, and what are the latest versions after the nugget. I want you to explore. Okay. So the latest 11 version, when it is released, and what is the API level. So I want you to explore and come for the next class. So we will continue in the next class. So if you have any queries or doubts, you can just ask me, or you can make text. So I'll be happy to explain you. Okay. So we have like only few introductory classes. So probably from the next class or the upcoming classes, we will be looking into the Android Studio in detail. Okay. So mostly I'll be talking like the theoretical aspect, and simultaneously I'll be like telling you how to execute it, so that it would be easy for you to map the things and work on programs much easily. Okay. Okay, then see you guys. Take care and be safe. We'll catch up tomorrow. Okay, bye bye.
Thank you.
Welcome.